So I'm going to go through a quick 15 to 20 to 25 minutes. So I have no idea how long it is. Then we have a panel. The talk is a great context-setting device for the panel because I'm going to go through a bunch of definitions and case studies. It's not going to be boring, but a bunch of definitions and case studies, and then me and my buddies are going to talk about what this all means. So yeah, that's me, Justin Glibert. This talk is Autonomous Worlds 101. I'm going to go through what I actually mean by that, but as a mean of introduction, I co-founded XeroxPark, which is a research lab you might have heard of. I lead a team called Lattice, where we're working on pushing the envelope of Ethereum and just blockchains in general, and essentially try to build the biggest possible on-chain apps and go through the different innovation in the technologies that are necessary in order to do that. So I want to draw contrasts between a couple of terms to make defining autonomous worlds easier. So first, what's the difference between a world and a game? So there are many ways to draw differences between those two terms, but there's one that just makes autonomous world as a concept a bit simpler, and that makes just more sense in general. So I define a world as a container for entities and rule set for how they behave. So as an example, the game of chess, or at least a single match, is a world. A game, at least from the perspective of a world, is a world plus a bunch of other stuff. So as soon as you add an objective, a leaderboard, a ranking, chat, and all that stuff, you start augmenting the world with social structures and playfulness. Because a world doesn't have to be playful. You can think of this universe. I mean, this universe is a world. It's just a set of rules, and it's not necessarily playful. It's when you add additional structures on top that it becomes playful. OK. And the other thing that I need to contrast is autonomy versus dependence, at least in the context of worlds. So, and all of this is pretty obvious, by the way. Dependence is the world needs a privileged entity, company, system in order to remain alive. And autonomy here means that the world can keep itself alive. So those two terms are like pretty opposite from each other. So if we assemble those two things together, what's an autonomous world? Well, an autonomous world is a set of rules and entities, usually programmed via code, that run on sovereign compute. And what I mean by running is that, like, worlds run on everything. You know, like Harry Potter runs on books and wikis. Worlds runs on tribal songs and databases. Here, what I mean by run is, what is the substrate that keeps the world alive? And in the case of autonomous worlds, it's sovereign compute. Today, I mean, sovereign compute is just computers that nobody can shut down. And the reason why it's actually quite interesting to think about computer this way is, today, we have really powerful computers, but they still need their daddies. You can unplug them, and then they die. So when you have sovereign computer, it's actually it's a regime shift in how we think about computers. And today, the technology we have for sovereign computers, blockchains, with a caveat that it needs to be well secured and decentralized. Maybe in the future we'll come up with different ways of getting sovereign compute. But today, and also that's the reason why people are here, we use blockchain in order to make things sovereign. So that means that the computer doesn't stop when the company goes bankrupt. It also means that the computer doesn't stop when the devs don't care anymore. So for the first time, we're kind of like giving autonomy to our programs. The computer just doesn't stop unless it's programmed to do so. And that's a bit scary. I could give an entire talk about why the people that are like AGI doomers should be scared about blockchain instead. Because for the first time, we have computer programs that have economic incentives that can't be stopped anymore. But today, we're not going to talk about that. So enough definitions. Why do we care? So I claim that autonomous programs are interesting. And as an example, maybe many people are here today because of DeFi, so decentralized finance. I want you to think about a DeFi as that it's just an autonomous financial computer. So autonomy here drastically changed the relationship we have with the system. Because if you subtract autonomy, as an example, if you run DeFi on PayPal servers with closed API, of course it wouldn't be called DeFi anymore, but it would be way less interesting. So the crux here is autonomy. And so we have a different relationship with autonomous systems. And that's because autonomy, more often than not, leads to longevity. Of course, you can get longevity in different ways, right? If you're a company that runs a computer program for 20 years without screwing up, there is a perceived longevity to this. So there are different affordances you can use to get longevity, but one of the most, the zeitgeist today is that you get longevity by buying autonomy. And how do you buy autonomy? You buy it from a blockchain. You can think of Ethereum as a company that sells autonomy. That's their product. They sell hundreds of millions of dollars worth of autonomy per year. That's the market, that's the market cap of block space. So imagine my little brother in the garage maintaining a ledger of transactions. It has the same API as Bitcoin. It's the same system. Does it have the same features? Well, of course not, because we have a different relationship to systems that are autonomous, even if they have the same semantic. And of course, caveat here, with Bitcoin you have transparency, enforceability, and so forth. But ultimately, the thing that matters the most is autonomy. And when people say decentralized, what they actually mean is autonomous. This whole decentralization stuff is mostly about the fact that, hey, nobody, including nation state, can come in and change the system, or at least change the system not according to the rules. So I'm going to, and that's one thing I'm going to keep doing during this talk is like start reframing things and make them a bit stricter. So we're talking about autonomous programs being interesting. Well, I think that first we have to go a bit deeper and say, well, autonomous rule-based systems are interesting because programs can kind of do whatever you want, right? They can generate random numbers, they can not accept input from other people, they can just do stuff that is not interesting. But stateful rule-based systems is actually what we're here for. And a useful mental model for rule-based systems is think about their rules as physics. So that might be a bit obscure. I'm going to go through some examples. But I think of physics as formal rules that define how a universe changes, right? So we have the real physics, like that defines how this universe changes. But you can think of the physics of chess, right? The physics of chess being the rules of chess. The thing that's interesting when you think about rules as physics is that it insists on one thing that physical laws have, and that's conservation laws. So conservation laws are rules that dictate how a quantity is conserved. So as an example, in our universe, energy is conserved, right? Angular momentum is conserved. Information to some extent is conserved. And all of those things actually make the rules amenable to having different systems and different agents in them coexist together. We have conservation laws in our day-to-day life that don't come from physics. They're just so obvious that we don't really think about it. And I'll give some example later. So rule-based systems have a physics, right? Like that's their rules. And as a way of illustrating this, well, like let's go through a couple of examples. And like I have three rubrics: rules, conservation, and agents. So for our universe, the rules are relativity, electromagnetism, and so forth. We have a couple of conservation laws. We have energy, angular momentum. We also have agents. So what are the things that interact with the physics? Well, in our universe, we have humans, cars, gods, maybe aliens. So now let's go through a slightly different example. Modern finance. So modern finance is a physics. It has rules, the Black-Scholes equation, the funding fees for perpetuals, there are a bunch of others. It has conservation law. Again, with caveat here, dollars are conserved. If I send you $1, I'm $1 off. If I were to keep my dollar, it would not work. So we have kind of like implicit conservation laws in those systems. And the agents that evolve in this physics are traders, market makers, derivatives designers, and I mean the people that hedge, more often than not the industry. Ethereum mainnet has a physics, right? Like the rules are the EVM, the conservation law is ETH. If I send you some ETH, I'm some ETH off. And the agents are MEV searchers, DeFi devs, collectors, and so forth. So the thing that is interesting with all of those physics is their multimodality. You have radically different kind of agents interacting with the systems, right? And so an additional claim on top of this is that most of the semantic of blockchain today is about ownership and money. So even if we have a big space of physics we can actually explore, we're restricting ourselves to a very specific type of physics and like the space of all the rules you could define. DeFi is just an autonomous physics, finance-like physics, right? That's what it is, if we use all the fancy definitions we've accumulated over the last 5 minutes. And the entities, there are tokens, vaults, debts, autonomous. It's not autonomous. I don't remember what the A in AMM stands for, okay? So it's AMM. And there are a bunch of other things as well. But really, why don't we start thinking about autonomous game-like physics, right? Because with the space of physics we're going to explore, we know that autonomy drastically changed the way we think about those systems and the way we relate to those systems. So why are we limiting ourselves to finance-like physics? And you would have things like resources, chemistry, embodiment, spatialness, all the things you don't have right now in finance because it would make the markets inefficient. So what happens if we change the physics? Well, that's my stricter definition of autonomous worlds. There are game-like physics running on sovereign compute. So that might have seemed very pedantic, this whole little thing, but it's here to give you intuition as to why we think this is interesting. And so the elevator pitch is, imagine the emergence, composability, and autonomy of DeFi, but applied to virtual worlds. And there are a couple of very interesting first-order consequences. The first one is that the worlds keep running if the creators are gone. That's completely unlike virtual worlds today, right? They're run on a bunch of servers. Sometimes, I mean, you know, people talk about Web3 games today. Sometimes their ownership are on a decentralized settlement, whatever. But like the core rules of the universe are run by someone, and if that person or that company disappears, so does the world. So the first thing I want to insist on is that the world lives forever unless it's programmed to die. The second one is that anyone can build on top of the world as long as they respect the physics. And this might seem like a good to have, but think about this universe. The people that built this venue didn't have to get the catalog of venue from gods and select the one they wanted out of the ones that were created by the game designers that got hired on Fiverr, right? They didn't need to get a certificate, they just did it. So the thing that is interesting when you have physics-like system is that the emergence is insane. You can build everything yourself, right? So, and I want to go a bit deeper into this because that claim is made by many things today, right? Like interoperability and composability is kind of a meme. And most Web3 games today, they have the ownership layer on chain, which means that the users can build on top of that layer, but they can only build things that relate to owning, right? They can build marketplaces, they can build lending markets and stuff like that, but they're stuck in a universe where the only verb is own, which is, it's a bit sad, also it's a bit dystopian. I hope we're not going to be stuck in a universe where the only verb we have is own. And so, compare this to autonomous worlds. Here, given the entirety of the rule set, that is the physics is on chain, the users can build anything as long as they respect the core physics, right? Kind of like in this universe where I can build anything as long as I respect the core physics. Things like government, demigods, quote-unquote faster trains. So today, a big problem in massively multiplayer games is the problem of content. You need teams that pump out content over and over again, right? Because if the players want faster trains, you can't let them make faster trains. You have to create a tech tree and call a game designer and be like, hey, can you make a faster train and balance it? And then they just do a bunch of stuff in a spreadsheet and then you put it there. What if people could actually build faster trains? If you think about Ethereum mainnet as an MMO, people build faster trains all the time. They build better DeFi protocols. They improve the actual core systems. And the Ethereum Foundation doesn't have to come in and add to the list of things people can research to literally the tech tree of Ethereum, the new kind of system that people are making. So one last thing I'd like to add in terms of first-order consequences of what happens if you build autonomous worlds is that it's client agnostic. So client agnosticity means that there is no canonical way to look at the world. And that's pretty interesting because today people build systems, video games, and then they build a canonical way to look at it, and that's it. You're kind of limited to this. And have to spend, and it comes at great expenses and inconvenience. If you think about the blockchain, Etherscan, Uniswap, and Tenderly, which is a debugging tool, are all different views on the same data. They're different clients. So if you think about it from the perspective of video games, you could have a set of rules, and really powerful people could look at it like Twitter. Here's an event log and message that people have sent. Slightly less powerful people, or people that are less involved, could see it like Google Maps. Here's my empire and what I can do in it. The people who are just getting started can see it in first person and go around and be like, wow, I have one gold coin to my name, so I'm just going to go around and look at what's going on, right? And those different clients could be built by different teams, different companies. It's all different views on the same system. My first case study in autonomous worlds is this game called Dark Forest that we built at 0xSpark. It's kind of old now. Some people here might have heard of it. Dark Forest, wow, this is horribly pixelated, sorry. Dark Forest is a real-time strategy game running on chain. So 3 years ago, a bunch of friends decided to say, hey, what if we take a game where you move energy between planets in a universe, we put all the rules on the blockchain, and the cherry on the top is that the universe needs to be discovered cryptographically. So when you start a game, you don't know where things are. You just know that things exist. And you have to spend computational power in order to explore the universe, kind of like mining for Bitcoin, or like any kind of proof-of-work system. And I think 20,000 players played it. At some point, it was the app that consumed the most amounts of gas across all chains. So that was pretty interesting. It was crypto native, so there were actually no servers. So that's something that really troubled people. Like, wait, you build a game that has no servers. What does it mean? What's the trick? Well, anyone could run a node and then join Dark Forest, which was pretty interesting. Actually, the players ended up running their own infrastructure. Our cloud bills were $0. We just paid to deploy smart contracts, and we're like, peace, figure it out now. There were no financial elements, so we know for sure that people played because they wanted to have fun, not because there was some incentive. It was the first use of zero-knowledge in smart contract in production. Again, production with caveat. We broke it many times. And yeah, Dark Forest was hackable, so it was client agnostic. People actually built different clients for Dark Forest. People could deploy smart contracts inside the universe of Dark Forest. And we played with this quite well. So this is Dark Forest Rust, built by Georgios at Paradigm. He rewrote Dark Forest in Rust in order to play faster. You don't see this with League of Legends. I mean, I don't know how it would look like, actually, because playing League of Legends faster with like a terminal would be actually quite hard. But Georgios was like, hey, guys, this web UI sucks. How do I play faster? Well, he didn't have to sign up as a developer or ask for an API key or join a partner program. He just did it, because it's a peer-to-peer network where anyone can interact with it the way they want. Nick, who created ENS, wrote a Dark Forest AI. I mean, it was more like a glorified rule-based system. And that just leveled up the meta. No, it was not humans trying to take planets from each other. It became a game of humans writing AIs trying to take planets from each other. So this is the equivalent of inventing fire in the universe of Dark Forest. This just totally changed the game. Of course, people built marketplaces. We were very intentional about not building marketplaces. We're like, hey, here's an obvious place for someone to come build something. You can do it. It's all smart contracts. You can extend it. And they did. We started having like 3 different marketplaces that started competing with each other. So that's pretty interesting, because had we built a marketplace, probably people would not have. And so we could have put some fees and said, those are the fees. And it would not have become a race to the bottom. Now this becomes a race to the bottom. All those marketplaces actually started cutting each other off with diminishing their fees. So that's pretty interesting. We're talking about like players building infrastructure. And then people started building super weird stuff. So in Dark Forest, given you know what the metadata of the planets are. So you know, wow, there is a level 12 planet somewhere in the universe. You just don't know where it is. So someone built this marketplace where you can put a bounty saying, I'll pay you $100 if you reveal to the world where this planet is. And then using zero knowledge, you can prove to the marketplace that the planet is actually there, and then you get paid. And that just started, at that time, it started becoming insane. So after that, someone made Night Market, which is kind of like the broadcast market, but it's private. So using some crazy ZK math, and I'm not going to go through the construction because we don't have time, and frankly, I don't think it's that interesting. But I can sell you the coordinate of a planet, and you receive it, and we can do all of this trustlessly. So we have private information markets that have been, like, people have speculated how we could do that on Ethereum. This is the first implementation of a private information market on Ethereum for a freaking video game. And so the thing that is interesting is, here you can see that video games are the bleeding edge of technology, more often than not. And that was, like, really well reflected with Dark Forest. Also, like, of course, people love proof of work, so they made faster miners. The Chinese were particularly good at it. We had so many Chinese DAOs that were just making faster and faster and faster miners. And then the thing that became really interesting, oh man, I only have 1 minute left. All right, I'm gonna speed run. The thing that became really interesting with the miners is that you can't prove to someone that you mined the map the right way. So you can buy a map from someone, but what they often do is they just remove the important planets. And so people started having maps of the worlds that were incomplete. And there was no way to prove to people that they had the right map. Couple of other crazy things happened, but I want to get to the next section before people kick me out of stage. So the thing we had a lot of rebuttals and like things that people said after Dark Forest. Like, well, Earn blockchain's slow. You're never going to go past slow strategy games. It took you 2 years for you guys to build Dark Forest. Like, how are you going to build something more complicated? So we assembled a team, that is. And we built this thing called MUD. We describe it as an engine for autonomous worlds. And MUD basically is a way to build really, really big applications on chain. We partner with those folks. I mean, OK, we don't say the word partnership. We collaborated with those folks. You might know of them, Optimism. They built this thing called the OP stack, which is a way to create rollups for application, so application-specific rollups. And we built OPCraft. So OPCraft is on-chain Minecraft. We put building and crafting and mining on chain, procedural generation. We built like a voxel client that runs in your browser. And we're like, hey, like, here's a cool game that you might have seen before, and we just put it on chain. So it's actually possible to go quite far. And of course, it just didn't stop at here's shitty Minecraft. It went well beyond that, given now we have new affordances of autonomy. So, OK, it's not the time for the video yet, but technician, get ready for the video. So OPCraft was fully on-chain, right? Procedural generation, in Solidity, we had crafting. The rule that is important here, because I'm going to show an example that used that, is that you could claim territory using diamonds. You can put diamonds in a territory and say, this is mine now. And unless someone overstake you, nobody but you can build and break blocks in that specific territory. So people really liked it. They made 3.5 million transactions in 10 days, which is almost as much as ENS. We had 1.5 thousand players that played. Video, please. So this is me and my friend trying to build a house in OPCraft. So there is not much difference between actual Minecraft. There are a lot of tricks. You can see the transactions confirming in the bottom left corner. We have a lot of tricks, like we simulate the transaction client side to make them go faster. We share like very precise positioning via peer-to-peer network. But to players, it just feels like the same thing, right? So at first, when we showed that to people at DEF CON, they didn't believe it. They were like, yeah, that's not possible. And then people started looking at our code. We had like 30 people in a room, like reading code and like, where's the trick? Where's the server? And there's no server. It just worked. Cool. Can we go back to the slides, please? Thank you very much. So people build cool, cute stuff, right? Like a team built a tool that allows them to turn any pixel art into a structure. So that's the Ethers Phoenix from the Optimism team. And then people started deploying things in OPCraft, because that's the point. Of course, someone put Uniswap there, so you can go to a specific place and like trade blocks. Kind of like if people here have played Minecraft before, there was this thing called Quick Shop that allows you to create chests where you can buy and sell things in actual Minecraft. People just did it on chain. But then things got super weird. And Supreme Leader OP appeared on Twitter, the benevolent god king of OPCraft. What Supreme Leader OP did is they mined 300,000 diamonds. We have no idea how. They probably botted it. And then they claimed every single piece of land around the chunk. They deployed a contract called the government contract, and they created a communist government. So if you install the Supreme Leader OP plugin, you can choose to give away all your properties to the government in order to join the government and share your inventory and your claims over land with the government. So after joining government, you would get a rank and a seed-to-lead ratio, kind of like in a peer-to-peer network. You have to mine more than you build. And then people started getting together and building monuments because of this, right? So this is what happens if you join the Supreme Leader OP government. Your inventory has a lot of blocks, so like 161,000 diamonds. They built massive towers made out of diamonds. That was their biggest flex. Here's Supreme Leader OP meeting inferior OP in the game. And all of this was done without asking us. The same way nobody asked Vitalik to build Uniswap. Actually, that's a bad idea because Uniswap is Vitalik's idea. But like any kind of auto apps, this was just a smart contract and a bunch of JavaScript that was injected client-side. It was completely permissionless. So this really highlighted the power of building on top of physics, right? Like you can extend things at any layer you want. Yeah, I'm really out of time. So the conclusion is that blockchains are scaling today. But we can already have app-specific L2s that can power those autonomous worlds. MUD, the engine we built, actually allowed us to build OPCraft in 2 months. So you can go quite fast now. Actually, I expect people to rebuild DeFi apps using MUD, given how good it is. We have already seen some social apps being built using MUD. Things that are not games, because people were like, hey, like, this actually makes it so much easier. So yeah, expect to see more and more autonomous worlds over the next year. Those are some things you can check out. And I'm going to go on the panel. Thank you so much.